Hello everyone. Today we are going to discuss about the steps involved in deploying open source large language models in Runpod.io. With lot of open source LLMs getting released day by day, when we want to perform a benchmarking test or perform a quick rapid prototyping, Runpod.io is very handy. So today we are going to see how we can deploy Mistral 7 billion model in Runpod.io using text generation inference. Let's get started. So the first step is to create an account and add some funds to it, and once that is done, we have to go to storage. Okay, so we are going to create a persistent storage for the setup. So click on new network volume, and depends on what type of GPU that we are going to use. So I'm going to use European region where RTX A5000 is available, and create add the volume name, whatever the name that you want to keep for your volume, say for example J1, and how many GB of storage that we are going to use. So for example 120 GB. So per month Runpod charges $0.07 per GB for the persistent storage. So once we click create, a persistent storage will be created like this. So for example, I have already created a storage TGI with 150 GB capacity in the European region. Now once this is done, the next part is to spin the pod. But before we do that, anyways, to access our models which is there in Hugging Face, we need a kind of an authentication. We basically need to set up the API key. To do that, go to the secret section and create a new token. Okay, create secret. So in the secret, you can give whatever the name that you want to keep for your secret. In this case, I'm just giving Hugging Face token. Right. So here you can copy token ID, which the Hugging Face token ID, which is there in the access token sections. Just copy paste it and click on create secret. The good thing about secrets is even if you click on this particular secret which is already created, it doesn't show the values, so it's pretty safe. Now once we have created the storage and the secret, we can go ahead and deploy our GPU. Okay, let's go ahead and spin the pod. To do that, move to the pod section, click on deploy. So we are going to deploy the GPU instance. Make sure you select the network volume which you created in the previous step. So in this case, I have already selected the network volume to be TGI, which is 150 GB in capacity. And we are going to choose our GPU. So let me select RTX 5000. So it has 24 GB of VRAM and it costs around $0.44 per hour. In the last video, we ran the same setup with Mistral in AWS 5.x large machine, which costed around $1 per hour for the same 24 GB VRAM. So it's almost half the price compared to AWS. And what we're going to do is we're going to edit the existing template. Okay, so here we are going to change a couple of things. The first thing that we are going to change is let's move to the text generation inference GitHub repo. So in the GitHub repo, this is the Docker command that we are going to implement in the pod. So we are going to copy the Docker image name. Okay, and we are going to replace it. So we are not going to use the default PyTorch image. Instead, we are going to use the text generation inference image. And the next thing, when the Docker image spins up, we have to provide a couple of mandatory parameters. So the first one is the model ID. So this specifies which model you are going to deploy in your cloud. So in this case, we are going to use Mistral 7 billion. And we are specifying that we are going to use deploy TGI import 8080. Right, and here the network volume is already selected. So this 150 GB of storage is the persistent storage. If you do not use persistent storage, still it's possible to spin. You can specify the number of GBs for this particular machine. But the problem being when you terminate the machine, since it's not persistent, all your setup goes off. So it's better to use a network volume, but it's still optional. Right, so the mount path, by default the workspace is the mount path, but since we have the network volume, what I'm going to do is I'm going to change the mount path to runpod volume / data. So this runpod volume is the volume that we created with 150 GB. So what are the model that we are going to download is going to reside in this runpod volume / data. And this is the part where we expose 8080 port, because if you want to run the same benchmarking or any test from your machine, like from outside the runpod environment, you have to expose the port. So I'm going to add 8080 here so that I can query the LLM which is running in runpod from my machine. Now there's one more important thing to note here is when we are setting up things, we have to set up the Hugging Face Hub authentication. To do that, click on add environment variable. We have to provide this Hugging Face Hub token. Remember, we created a key, Hugging Face secret key in our runpod environment. So click on this key button. So select secret and select the Hugging Face token. What are the secrets that we have created? Now this is pretty much it. So first is the image name, second is the container starting arguments, third select your appropriate network and its mount path, and fourth expose the port, and last make sure you have set up all these authentication steps. So once that is done, click on set overrides and we are good to go. You can click on deploy on demand. So let's wait for a few minutes. The pod will spin up and we can see the logs where TGI starts up and it shows the relevant logs. So let's expand it. Right. So let's wait for the setup to get completed. The deployment is completed. Let's go ahead and check the logs. So here we can see in the system logs the TGI's Docker image has been downloaded and extracted, and in the container logs we can see the Mistral 7 billion model is downloaded and the model is up now, right? So let's quickly go ahead and send in a couple of requests. To do that, I'm moving to the notebook. So let's import requests model, right? So our endpoint will be https:// here we have to find the pod ID. So move to the pod section and here we can find a alphanumeric number, copy that, and this is going to be our pod ID, right? So let's do -8080, the port in which we deployed, .proxy.runpod. Right? So this is going to be my endpoint, and we are going to send in a prompt. Right? So our prompt will be inputs : what are the prompt that we are going to send? So tell me a joke. So what I can do is import JSON here. So JSON.dumps of this will become a string. So headers will be content type application JSON. So we are sending in a JSON string. So we have to define three parameters. One is our endpoint, other one is the prompt, and third one is the header. Now what we can do is, so JSON is not defined. Let's show this. Okay. Now let's go ahead and do request.post. We are going to make a post request. Our URL will be endpoint, and the headers will be headers, and the data, the payload will be prompt, right? So let's save this in response. Wait for the response to be completed. Yes. Let's print a response.status code. Here the status is success, and response.text will be the actual response from the TGI server. So here you can see this is a tell me a joke is the prompt that we sent, and here is the answer. And we can also confirm that by looking into the logs, right? See the request that we have sent got generated, and we are able to successfully get the response. So as we can see, setting up the text generation inference in Runpod environment is fairly straightforward. All we have to do is to set up the Docker command, the images and the arguments properly in the UI of Runpod. And once we expose the port, we can use the notebook to query LLM with whatever the prompt that we are designing. So we can use this for a quick benchmark test, or you want to develop some prototypes, or you want to deploy some application based on LLM, which wherein you can send some prompt and get the responses. I hope you enjoyed this video. If so, hit the like button and subscribe to the channel. Thank you.